Hi. As part of what we hope to be ongoing skill sharing sessions for our volunteers, Jackson agreed to share some of what he knows about micro soldering. We're going to join that session, which is already in progress.
This machine, if people are familiar with, hot air guns that you stick into a wall, it's kind of just like a blow dryer on steroids. So this is very similar. You can control the temp individually, so it'll peter out at whatever temp you set it at, kind of like a soldering iron. You can also control the airflow, and that matters for specific things that you're doing. There are some cases where, let's say you're working with a bunch of really, really small individual resistors and capacitors. If you have a really high airflow, there's a chance that you might push everything away. But at the same time, if you're working on a really large BGA chip or a really large chip that has a lot of thermal mass, you need a lot of airflow on top of heat to try and heat the whole thing at the same time, rather than creating a hot spot right in the middle that could damage the chip. So this chip I'm about to take off, right here, what do you call it? Yeah, the CD3215. It's basically the primary charge controller for the USB ports on a MacBook Pro. It fails all the time, like truly all the time. So people get very familiar with replacing these.
Now what's that?
This right here is flux, specifically Amtech flux, which is a type of non-corrosive flux. It's really important, especially when you're doing surface mount soldering, to have a form of non-corrosive flux. Flux essentially helps create a more spreadable heat zone. It makes things all work kind of the same temperature and transfer heat better. The specific reason why you want a non-corrosive flux is because you can't get all the flux out from underneath a surface mounted component. You can try your best, but you'll never get it all. So some flux will corrode whatever it touches over time because it could be slightly acidic. You want to try it and avoid that as best as you can. So we're going to add a little bit of flux around the edges. You don't need a ton. It gets
Should I move away from this direction if it's
it's not going to be getting hot. Basically, the only times I ever really burn myself is if I'm holding my tweezers right here and I've got my hand right next to it. So I typically stay around 400C. Some people like to go right at the threshold of whatever solder they're using. It's like 380 and 375. With older non-leaded solder, 400 works pretty well for me. And then heat, or the air speed around 50% for like regular surface mounted components works pretty good. If it's a really small resistor, I do 30 or 20. If I'm working with plastic, trying to surface mount a plastic component, I do lower heat and really high air to try and just get it all working really quickly. In this case, we will get started. So you kind of want to go in a little bit of a pattern. You want to get that hot air spreading around. You'll be able to see in just a moment that underneath this component, it will start bubbling. It's kind of right there. Can you see that? The bubbling lets you know that it's getting underneath, it's getting hot. So one of the ways that you test when you're surface mount soldering with a hot air gun is you try to poke your components. So if it doesn't move at all when you're poking it, it's not quite liquid yet. The main issue with removing components with hot air is it's really tough to tell when everything's fully liquid. And so people will make the mistake of just assuming it is if one of the corners lifts or something and just pull right up. A lot of times that's where I find people have lifted a trace or they've ripped a pad off or done something that, requires further repair. It can be, for the most part, avoided if you just give it a nice little tap over time.
Do you have concern about heating up the neighboring components?
Not really. I mean, it can be a concern. I have definitely burned my fair amount of chips, but that's on like really large BGAs that I've done like 7 or 8 heat cycles on. Really, you're trying to work within the bounds of this chip, getting to its melting point and then just lifting it. You're not really heating it beyond that. And these boards are really great heat sinks. They're amazing at distributing hot air. So things don't usually get too overwhelmed. You can run into issues if like the non-leaded solder you're using is really, really old or a different composition. It can just take so much heat to take it off, and that's why we replace most components with leaded solder. just to have better results. Oh, you guys see that? Okay. So I'll take heat off because I know it's at kind of the right temp. I'm about to poke it. Oh, okay. They cool off really quick, and that's kind of why you have to keep the air there the whole time. You have to poke it now and shift it. And then through surface tension, it pulls itself back to where it needs to be. That's one of the main benefits of this kind of style of soldering. Apologies on the shaky hands.
So right now, are you watching the screen as opposed to watching the?
So I've tried to teach a few separate people how to solder with hot air. That's the largest disconnect I've seen is looking at the screen while using your hands.
Yeah.
It can be very tedious. Also, you guys can see kind of the ramifications of using too much air. All of these capacitors and resistors have shifted. I'll show you how to resolve that. It's quite easy for the most part. But you know, in a loose demo where I'm not particularly concerned with the overall outcomes, it's just fine by me. So we'll add some more flux. And I'll show you guys kind of how these resistors and capacitors go back in place. So reduce the air so I can nudge them a little bit without having them fly away.
So there are little jumpers on those inner pads. Those wire traces that look like copper traces.
Oh, these right here?
Yeah, yeah.
Yes, so those are conformal coated. It's a very thin conformal coating, but you can actually run into issues with this style of soldering because I'll show you, like, the next step typically is you take your solder wick and you wick up all of the solder balls before you remount it.
Right.
When you wipe with your solder wick, you do erase some of that conformal coating, and if you do it multiple times, which I have done, you actually erase all of the conformal coating in between the pads, and you have to make your own. Otherwise, your solder balls will merge underneath, and you'll run into shorts on your components. So it can be quite frustrating. It's kind of you have one or two good tries before every try is harder and harder and harder. But in this specific instance, you'd be able to just put it back, the new component, without any real small issues.
So for chips that small, do you really need the flux?
Yes, it's even more critical because you want your solder to be as mobile as possible, so all your components can self-align.
I mean, if you didn't use flux, if you're just wanting to take things off, so you had like a blank board, would you still use flux?
Yes, because it allows you to use lower heat,
Okay,
and it'll
that helps.
operate a little quicker.
For this type of rework, does it ever make sense to add leaded solder on top of it to try to get
For sure.
non-leaded stuff to work? Okay.
It can for sure definitely help. The main issue is with these small components. It can be your risk of merging them and then having to clean the solder off is pretty high. You can see I'm just kind of passing these guys along, and they kind of want to go back to where they came from. They don't necessarily want to be. Now that I have the components kind of where I want them to be, if they look a little ugly, you can add a little bit more flux. And then add a little bit more air and have them hopefully self-align when you get it all. You kind of need a little bit of extra air if you want them to self-align, because you want them to kind of push themselves into the right place. It's definitely a balancing act. You'll, if you guys ever get into hot air reworking, you'll find that everything is touch and go with your air, your heat, and depending on how picky you are. Jumping. This one's probably about to jump where it wants to be. Come on. Maybe these guys. I guess they're all done jumping. Okay. So that's kind of the main premise of this type of soldering. If you take something off that's a little bit larger, so you can get a view of that. In this case, this is where I would add leaded solder. So on these little components here, It makes a little bit more sense that you can kind of stick your iron in there and not have any issues.
Why leaded versus unleaded?
The melting point is just so much lower. It's like at least 30 C, and it doesn't oxidize the same. So with non-lead solder, you can get an oxidized external layer that is a little bit more resistant to hot air helping melt it. With leaded, you don't really have that issue. It, for the most part, stays nice and shiny and non-corroded for a very long time. And then the melting point helps substantially. It allows for you to melt the solder, get everything connected before the chip reaches the same temperature. Bring the airspeed back down again since we aren't particularly concerned about aligning anything. So if anyone saw right here, this changed from a kind of pointy lumpiness to a nice smooth surface. Usually I go based off sheen to tell that something is melted all the way, but you can also see it align in a more uniform way to give you the content. So just take these off, put them over here, and then vice versa. You wait for your solder to get nice and melty. Or you can put it down early too, doesn't really matter. You guys, I don't know if you guys saw, it tried to leave me there. Sometimes you have to change the way that you're articulating this.
The goal is just the solder, you got like the surface tension with solder and you're trying to float the part to the top of the bubble or something?
Yeah, basically your entire goal is to just get the natural like surface tension properties of the two metals conjoining to just get in contact before this tries to fly away or like before something tries to melt.
So this skill sharing session went on for about 45 minutes, and Jackson was really generous with his time and his information. And he basically went anywhere we wanted to take him. People asked questions about basic troubleshooting and how he got into all this. And if you want to see all that, it's available on the unedited reel. But we're going to call this clip done for now. So thanks for stopping in, and we'll see you next time.